In this video, we're going to solve a radical equation that has two radicals in it. This is probably the trickiest of all the radical equations that you'll encounter in Math 111 college algebra. So here I've got the square root of x plus 7 minus 2 equals the square root of x minus 9. Now when I see those radicals, I think that the best way to get rid of them is to square both sides of the equation. Now since this radical is already isolated, I'll go ahead and square both sides of the equation to undo this radical. So on the right-hand side, the squaring and the radical undo each other, so I'll be left with x minus 9. However, on this side, there are two terms. So when I square the left-hand side of the equation, I'll have to FOIL this out. I usually write it out as the square root of x plus 7 minus 2 multiplied by itself, the square root of x plus 7 minus 2. It helps me to see the two pieces written out next to each other before I FOIL. I'm also going to use my highlighter here to remind us that this thing in pink, the square root, is one object when I'm FOILing. So now when I multiply my first two terms together, I get the square root of x plus 7 multiplied by the square root of x plus 7. I'm going to write that down right now, although you may have already realized how it's going to simplify. Now, when I multiply my outside terms, I will end up with this negative 2 times the square root of x plus 7. And similarly for my inside terms, negative 2 times the square root of x plus 7. And my last terms, finally, negative 2 times negative 2 is positive 4. And on the right-hand side, I still have x minus 9. Now we're going to clean up the left-hand side a little bit. Notice that this is the square root of x plus 7 multiplied by itself. So the square root is being squared. That means that it cancels itself out, and I'm left with just x plus 7. Now these two, I have negative 2 square root x plus 7s and another negative 2 square root of x plus 7s for a total of negative 4 square root of x plus 7. And I've still got this 4 over here. It looks like we could do a little bit of cleanup here still, since I can combine the 7 and the 4. So I'm going to go ahead and do that. I've got x plus 11 then, minus 4 times the square root of x plus 7 equals x minus 9. Now that we have an equation with one radical in it again, we're about halfway there. Now I'm going to isolate this radical, and then I'll end up squaring both sides of the equation. So to isolate this radical, I start by subtracting this x and this 11 from both sides, so that I get negative 4 square root of x plus 7 equals, on the right-hand side, the x's cancel each other out, and I have negative 20 on the right-hand side. Now, I still want to finish isolating this radical, so I will divide both sides by negative 4, which gives me the square root of x plus 7 equals 5. Finally, we're almost there. The radical has been isolated, so I can square both sides of this equation to get rid of the radical, to undo it. Right. That leaves me with x plus 7 equals 25, and then I can subtract the 7 from both sides, which gives me, finally, x equals 18. Now remember that when you're working with a radical equation, you should always double check that your answer actually is within the domain of the original equation. So I'm just going to give you that reminder. I'm not going to show that to you again, but do double check that your solution is in fact in the domain of the original equation. It is possible to get extraneous solutions. I don't think this one is though.